Okay, so imagine this for a second. You step out your front door, pull out your phone, tap an app, and this sleek car just pulls right up.
Hmm.
No driver in the front seat. You hop in, say where you want to go, and it just handles everything. Traffic, turns, gets you right there.
Yeah, it really does feel like something out of the future, doesn't it? But
Yeah.
it's becoming very real.
Exactly. And that's the heart of what we're diving into today. Tesla's really ambitious robo-taxi vision. And, the thing is, it's not just about cool driverless cars. We're talking about something that could potentially reshape transportation economics on a, well, multi-trillion-dollar scale.
Absolutely.
Yeah.
And we've been digging into this really interesting video breakdown. It's quite technical, but super insightful.
Yeah.
And the most compelling part, the person making it. They filmed the whole thing while actually riding in a driverless Tesla RoboTaxi.
Seriously, through Austin, Texas, right? No one up front.
No one up front, just cruising through Austin. It's quite a statement, both symbolically and, practically, about where the tech is headed.
Wow. Okay, so that's our mission for you today in this deep dive. We want to give you the shortcut, basically. Understand the core claims Tesla's making, get a handle on the tech underneath it all, and crucially, grasp the huge financial implication.
And especially what makes Tesla's approach maybe different from others.
Exactly. We'll pull out the most important bits, the key insights, so you really walk away feeling like you get it. Ready to jump in?
Let's do it.
All right. So, speaking of those huge financial implications, one of the things that just leaps out is this economic claim, the idea that each Tesla robotaxi could eventually net the company something like $150,000 in annual profit.
Yeah, that number, it definitely grabs your attention. $150K per car, per year.
What does that single figure even mean for the business of getting people around? It feels like it changes everything.
It absolutely could. Think about the standard model now. Uber, Lyft. They take a cut, but a huge chunk goes to the driver. Fuel, maintenance, insurance tied to the driver.
Why?
Tesla's model, or this projected model, assumes charging similar rates, maybe even slightly less eventually. But you remove the driver cost, which is massive. And if their production and operational costs are significantly lower,
Then the margin just explodes.
exactly, the profit per mile could be unprecedented. It's not just selling cars anymore. It's selling transportation as a high-margin service.
Yeah.
It turns a car company into potentially something quite different, an economic engine built on autonomy.
Okay, so run the numbers slightly. If one car makes $150K, that's more than a lot of small businesses make in a year. It almost makes you wonder, why isn't every single car company laser focused on exactly this path? But okay, scaling it up. How many cars are we talking about for this to really matter for a company as big as Tesla?
Well, the models suggest that if they can get, say, 1 to 2 million robotaxis on the road, and that sounds like a lot, but given their manufacturing output,
It's not totally crazy for them.
right, it's within the realm of possibility over time. If they hit that scale, you're potentially looking at hundreds of billions in profit, not revenue.
Hundreds of billions, okay.
And now it's super important to stress, and the source material is clear on this too, this is a financial model. It's a projection for discussion, okay? Not investment advice. Definitely not.
Gotcha. Crucial caveat, but the potential scale is just hard to ignore.
It really is.
So, okay, let's dig into how this actually works, or how they hope it will work. There's this bottleneck mentioned, the ratio between the cars out on the road and the humans supervising them. Teleoperators, they call them.
Yes, the teleoperators.
Yeah.
And that ratio, that's arguably the real linchpin for long-term profitability.
Why is that the bottleneck specifically?
Because every human involved costs money and limits how many cars can be managed simultaneously. Think about it. If one person can only supervise, say, 10 cars effectively, you need a huge workforce to manage a fleet of millions. But if one person can supervise 50 or 100 or eventually even more cars because the AI is so reliable.
Then the whole system becomes much more scalable and cheaper to run.
Precisely. Fewer teleoperators per car equals higher profit margins, faster expansion. It's a direct relationship.
So making the system incredibly safe isn't just about, the obvious ethical need, which is paramount, of course.
Of course.
But it's also a massive economic lever for Tesla. A safer car needs less human oversight.
Exactly right. Safety is the economic enabler here. Better autonomy reduces the need for human intervention, which directly cuts operational costs and boosts the profitability of the fleet, which naturally leads you to ask, well, How are different companies trying to solve this problem? How do they approach building this safe, scalable autonomy?
Yeah, and that brings us to this really fascinating split in the road, philosophically speaking. You've got Tesla's path, which is described as AI first,
And
and
that
you have most of the competitors like Waymo, Zoox, Cruise, using what's called a brute force sensor fusion strategy. Very different ideas.
very different. And the contrast in the actual hardware, the design choices, it's stark. Let's take the brute force approach first. Waymo, Zoox, those guys.
Okay.
They load up the car with sensors. We're talking complex, expensive stuff. LiDAR, high-definition radar, ultrasonic sensors, constantly updated HD maps. A whole suite.
And that stuff isn't cheap, right?
Not at all. The estimates we saw put the cost per vehicle, just for the autonomous kit, somewhere between $145,000 and maybe $200,000
Oh, for one car.
for one car. Some reports suggest a single Waymo vehicle might cost, hardware-wise, more than 10 times what a comparable Tesla costs off the production line.
10 times.
Plus, their approach often involves a lot of complex human-written code, specific rules to handle tricky situations, what they call edge cases.
Okay, so that's one way. Complex car, lots of sensors, lots of code. Now, contrast that with Tesla. You called their approach AI native.
Right, and hardware-wise, it looks almost basic in comparison. Tesla uses just 8 cameras, standard automotive-grade cameras, basically, and a relatively simple onboard computer. The estimated cost for their full self-driving hardware package, maybe around $2,000.
$2,000 versus potentially $200,000.
That's the ballpark, yeah. It's a massive difference. And here's the key. Tesla shifts all the complexity away from the car itself
Shifts it where?
to their massive data centers,
Yeah.
to their training clusters, things like their Dojo supercomputer or the newer Cortex 2 cluster they're building out in Texas.
Ah, so the brain isn't really just in the car, it's in the cloud, constantly learning.
In a way, yes. The car has the necessary processing power to run the trained AI model. But the heavy lifting, the learning, the refinement, happens in these massive data centers. This is why they believe they can scale faster. The cars are relatively cheap and quick to build.
Right.
And the system gets smarter through collecting data and retraining the AI models, not by teams manually updating code for every single car or relying on super expensive hardware per unit.
And that scaling potential is just nuts. I saw a comparison that Tesla builds about 1,500 cars, which is roughly the size of Waymo's entire fleet right now. Tesla builds that many cars every 5 hours.
It's an incredible manufacturing pace.
Yeah.
And it points directly to what you might call Tesla's real secret weapon here. It isn't just the cameras or the car. It's that training infrastructure. It's Cortex 2.
Tell me more about Cortex 2. It sounds like the core of their strategy.
Think of it like this massive digital factory, but instead of stamping metal parts, it's forging intelligence. It processes unbelievable amounts of driving data, both from simulations and real-world driving.
Simulations too.
Billions of simulated miles, apparently. Testing edge cases, weird scenarios, things that rarely happen in real life, but the AI needs to handle. It learns from all of this, constantly refining the FSD software. So effectively, they're pre-learning countless situations in the virtual world before the software even gets deployed to cars.
So they offload the learning complexity to the cloud, keeping the car hardware simple and cheap.
Exactly. It's the polar opposite of the Waymo approach, where the complexity and the cost is baked into each individual vehicle.
Okay, so how does the learning actually happen? You mentioned real-world data. Where does that come from?
It comes from the massive fleet of Tesla vehicles already on the road globally, specifically the ones whose owners are participating in the FSD beta program.
So regular people driving their cars?
Yep. The system collects data on when the FSD system is engaged, when drivers intervene taking over steering or braking.
Ah, so it learns from mistakes or near mistakes.
Both mistakes and successes. It also observes general human driving patterns. All this data, anonymized of course, gets fed back into those training clusters. It's like teaching an AI by showing it millions of examples of good and bad driving and letting the neural network figure out the patterns.
Neural networks, like complex computer programs that kind of mimic how a brain learns?
That's the basic idea. They process these huge data sets and essentially get smarter, better at predicting and reacting over time. It's a continuous global feedback loop. The more cars are driving with FSD beta, the more data they collect, the faster the AI can potentially improve.
And that ties right back into their manufacturing advantage, doesn't it? Making over 1 million cars a year.
Absolutely. More cars mean more data, faster learning cycles, and the low cost per unit means they can pursue this strategy of, well, essentially flooding the market.
Flooding the market.
Think about it. A single Tesla Gigafactory can pump out more cars in a few days than the entire current Waymo fleet. The long-term strategic play seems to be use mass production to get millions of these low-cost, AI-powered robotaxis into cities.
Create network dominance like Uber and Lyft did.
Exactly like Uber and Lyft, building that network effect where more cars attract more riders, which justifies more cars.
Yeah.
But the killer difference is Tesla wouldn't be paying drivers for each ride.
Right, that's the potential for those huge profit margins again. It sounds like a winner-take-most or maybe winner-take-all scenario if they pull it off.
It certainly has those characteristics. The cost advantages and the scaling potential are significant differentiators.
So let's just quickly recap the key differences, pulling it all together.
Yeah.
Strategically, how do these paths diverge?
Okay, so summarizing the contrast, drawing from the source,
Yeah.
cost per unit. Tesla, maybe around $2,000 for the FSD hardware versus Waymo Zoox at $145K to $200K. Huge gap.
Okay.
Scaling speed, Tesla building 1,500 cars roughly every 5 hours versus competitors with total fleets still in the low thousands after many years.
Right. Manufacturing muscle.
AI versus code.
Yeah.
Tesla betting purely on AI learning from data versus others using a mix of AI and significant human-written rules for edge cases.
Got it.
Sensors. Tesla using just 8 cameras versus the complex, expensive suite of LiDAR, radar, GPS, ultrasonics used by others.
Simpler hardware for Tesla.
Learning. Tesla learning from a global fleet of customer cars in diverse conditions versus competitors often relying more on structured testing on predefined routes.
Okay, that paints a pretty clear picture of two very different bets.
It really does. You have one side building these incredibly sophisticated, expensive, individual robotic units, almost perfecting the single robot car. And then you have Tesla building this vast, data-hungry intelligence network that's designed for mass production from the outset. The strategic bet is clear. If Tesla's AI can reach the required level of safety and reliability at scale,
Then their cost and deployment advantages could just overwhelm the competition.
that seems to be the core thesis. Lower costs mean they can undercut on price, deploy more vehicles faster, achieve that network effect, and potentially capture a dominant share of the market. It's fundamentally an AI-first, software-driven, hardware minimalist strategy.
It's definitely bold, a huge bet on AI getting good enough, fast enough.
It is. And this whole grand vision, this multi-trillion-dollar potential, it really hangs on 3 critical things succeeding.
Okay, what are they?
1, the AI has to keep improving. Relentlessly. It needs to get demonstrably safer, more reliable, handle more and more complex situations. That's non-negotiable.
Right. Continuous improvement.
2, regulatory acceptance. This is huge. Governments, cities, safety regulators, they need to be convinced these systems are safe enough to operate without human drivers, and they need to create the rules for them to operate legally.
Yeah, the legal hurdles could be massive.
And number 3, public trust. At the end of the day, people have to want to get into a car with no driver. They need to feel safe, confident. Without public acceptance, the best tech in the world won't matter.
AI, progress, regulation, and public trust. Those are the 3 legs of the stool, basically. If any one of them wobbles.
The whole thing could stall, or at least be significantly delayed. It needs all 3 to really work as envisioned.
So, wrapping this up, if Tesla can actually thread that needle, navigate those challenges, the potential impact is just enormous. We're talking disruption on a massive scale, huge profits. It could change daily life for millions, billions of people.
It really could. Which leads to maybe a final thought, something for you, the listener, to chew on.
Yeah.
Given how fast AI is moving across many fields, not just driving, and considering these absolutely staggering economic forces pushing for autonomous systems, how much of our future world, really, might depend on how quickly we as a society can adapt, our trust, our regulations. How ready are we for infrastructure, transport, maybe even other areas to become autonomous?
That's a big question. How much does our future hinge on our ability to trust the machines and regulate them wisely? Definitely something to think about.